Hello and welcome to Engineering Simple. In this example, I'll go through a calculation that involves motor efficiency, output and input power. This would be useful when you're taking the FE or PE exam. So let's assume we have a balanced three-phase synchronous motor load that absorbs 75 kVA at a power factor of 0.85, leading when the voltage is equal to 2.4 kV RMS. The synchronous motor is operating at an efficiency of 80%. So the question is, what is the output power in horsepower? What is the output power in horsepower? So as I stated in previous videos, anytime you have a problem, it's really good to probably make a sketch or something, kind of like, and put a label each component on the sketch from the information given in the problem statement, and try to relate them how they relate. So as an example, so in this case, I have a synchronous motor. So I'm just going to put a circle around M. So that's a motor. So this motor takes an input power. So I'm going to call P in, means input. And it gives us an output, which is P out, which we want to calculate in horsepower. So we know this motor is operating at an efficiency of 80%. And we know this power here. So the input complex power is 75 kVA. Using the power triangle, the active power is the power factor times the complex power, which is 0.85 times 75 kVA, which gives me the input power is equal to 63.75 kilowatt. So you see this sketch here, kind of helpful, instead of reading the problem, it's kind of hard to make sense of all the information like mentally. So by making a simple sketch, I kind of relate things. We know efficiency is P out divided by Pn, because what is efficiency? I'm going to give it an input and I'm going to get an output. How much of that input I'm going to get out? That's efficient, how I can determine efficiency. So now you see I made a little sketch. So now basically I can solve this problem. So again, if you draw the power triangle, I would recommend watching videos that I made on this case. So P, Q, S if you have the power or power factor angle. So I know cosine, this is if you don't remember the equations that relate the complex power to the real power, or and so on and so forth. So really just do some trig. Cosine theta is equal to the opposite, sorry, cosine theta is equal to the adjacent, which is P, adjacent side, which is P divided by the hypotenuse, which is S. So P is equal to S times cosine theta, which is power factor basically. So P is 75 kVA, which is given, times cosine theta is basically power factor, which is given 0.85. So I get 63.75 kilowatt. And what is this P? It's really the input power, so PN. So I know PN, and I know efficiency from here is P out divided by P input. I can rewrite it here. Divided by Pn. I know efficiency, I know Pn. I can calculate P out is equal to efficiency times Pn. So P out is equal to, efficiency is 80%, which is 0.80, times Pn, which is 63.75 kilowatt. So P out is 51. Is 51 kilowatt. So I have 51 kilowatt, and I know 1 horsepower is equal to 745.7 watt, just watt. So 1 horsepower is equal to 745.7 watt. So I know watt cancel. So I have 51 kilo, which is 1,000 basically. So 51 times 1,000 times 1 horsepower. Divided by 745.7. So if I carry out the calculation, I get 68.4 horsepower. So one thing to remember, 1 horsepower is equal to 745.7 watt. Typically when you are dealing with motors, horsepower is used instead of watts. So hopefully you find this video helpful, and motor calculations typically show up on FE or PE exam. So have a great day.